Lesson 11.5, Dividing Polynomials. Our objective today is to divide a polynomial by a monomial and also to divide a polynomial by a binomial using long division. The standard is Algebra 1.6.5. So this is going to take you back to division the way you learned it when you first were learning division and not using a calculator because it wouldn't work that way. So the first part's pretty basic, dividing by a monomial. So what happens if that's the case? You should write the monomial under each term of the polynomial and simplify it, and then however it is left, that's how you leave it. Some of them might even look worse than they did at the beginning of the problem, but that's the way it works. So let's show you this. Example 1, 4x squared minus 18x divided by 2x. So here's what you will show as your work. You will write 4x squared over 2x, and then minus in the middle because there's a minus before the 18x, 18x over 2x. And you will reduce both of those to end up with two terms. So basically, however many terms were in the beginning polynomial, that's how many terms you will have in your final answer. So the 4x squared over 2x, when I look at that, I know that the 4 and the 2 become a 2 and a 1. And with the x's, there's 2 x's on top and 1 on the bottom. So the 1 on the bottom is gone completely, and the 1 on the top would be reduced to just one of them. Now, since there is only a 1 on the bottom, you don't write it. It would be just like reducing it to a whole number. So that very first term would be now 2x. You're going to have minus, so whatever sign was there to begin with, that's what sign you're going to have unless you're dividing by a negative. In this case, we're not, so the signs will remain the same. 18 and 2 reduced to 9 and 1, and then the x's cancel each other out. So you would end up with 2x minus 9. Questions about that? All right, example 2, 2y squared. Question?
Yeah, could you just technically write it all over 2 instead of doing the minus?
You write each term in the first polynomial over what you're dividing by. So I'm not sure if you're asking you can only write 1 2x. Nope, you need to write it under every term. You need to write it under every term. Because it's not going to always turn out nice and pretty like that, Zach. So you need it really under each one. Okay? Yes?
So when you're doing it, you would cancel out your sign. Would you cancel out the signs of like 2x and h when they become x?
Okay. Would I cancel out what part?
Like cross.
No. You only look at each individual term where it's listed and just cancel from top to bottom just right there at that individual term. Okay? Maybe the next example will help you out a little bit. Okay? That might help you see. All right, so 2y squared minus 3y minus 9 all divided by 3y. So here's what we would have to write then. So 2y squared over 3y minus 3y over 3y minus 9 over 3y. Each one of those it's basically an individual problem. How many terms am I going to end up with? 3. Good. Okay, so you cancel them one at a time. The 2y squared over 3y, the 2 and the 3 don't cancel. So they're just going to be in the answer. Nothing's going to happen to those. And the y's can reduce, though. There's 2 on top and 1 on the bottom. How many can I cancel out? 1. So this one's gone. Oops, I wanted to change that to red. So this one's gone. and that 2 becomes a 1. So that particular term would be 2y over 3. And it's going to stay that. Nothing's going to change. Okay, minus 3y over 3y. Well, what happens when something is over itself? What's it reduced to, Jared? Yep, so that's just going to be a 1. Minus, now this last one, 9 over 3y. The 9 and the 3 will cancel to a 3 and a 1, but that y on the bottom, there's nowhere to go with that. It's going to stay right there. So that last term is going to be 3 over y. So see how that looks like way messier than where we started? It's 2y over 3 minus 1 minus 3 over y, and that is your answer. Now, did that help answer any of the questions you had from the last one maybe, or not? No? You really need to see each one individually and see what's remaining.
Oh, yeah,
Ben, you got it? Okay, good deal. Yes, Ethan.
What if in the answer it was 2/3 over 3/2? Could you like cross them? If it was like
2/3 over 3/2. So then that'd be you'd have to end up making that a multiplication by the reciprocal, right? And we'll talk more about that next week. What?
What if you get like your problem is 2y over 3 minus 1 minus 2y over 3 and then make that happen?
Probably not. No, that's not going to happen. Okay, anybody else? All right, so that was the part, that was the good part. Not that this is bad, it's just going to take you back to long division from a long time ago. It's been a long time since you guys actually probably done long division the way you did when you first learned. But you've got to understand what you did when you first learned, maybe to understand this polynomial division. So let's review long division with the numbers here. 105 divided by 5. Let's think about all the things that we have to do. Well, you start off first by trying to take 5 into 1. And does 5 go into 1? No. So you don't write anything above that 1. So then you go 5 into 10. And does 5 go into 10? Yes. So you write how many times 5 goes into 10 over which one of the numbers, though? 0. And it goes in there twice. And then recall what you do at this point. What do you really do, Octavia?
Subtract 10 from 10.
Well, no, go back up a step. You're getting ahead of yourself. I want you to think of everything you have to do. Where'd you get another 10? Where'd you get another 10? Yes, you take your 2 times 5, and you get 10, and you write it down here. Now you subtract, and there's nothing there. Sometimes there's leftovers, sometimes there's not. Now what do I do?
bring down the 5.
Then you bring down the next step, the next part, the 5, and you ask yourself, how many times does 5 go into 5? 1, so you put that directly above the 5. You multiply. 5 times 1 is 5. You write it down here. You subtract, and you hope you get a 0. What if you don't get a 0? Now, I'm not talking decimal division. Let's talk about way back when. What happens, Jared? Nope, we don't want to keep going. Nope, we're not doing decimals. You get to the end and it's not 0. Mia? You have remainders. Oh my gosh. And that's going to happen here. Trust me. We're going to have some good fun right now. Okay, are you ready? Here we go. Here we go. So, yeah, remainders. You put a little R. Forgot all about those guys, didn't you? Okay, remainders. Here we go. Now, shh. I'm just going to tell you. When you're having a division like this, so 2r squared plus 5r minus 3, and you're dividing by r plus 3. Because it's a binomial on the outside, it's never going to go into that first term. There is nothing you're going to be able to multiply by that binomial to just give you one term. Okay, so there's never going to be anything over the first term. So, but what you've got to do, so it's always going to end up being written over here. Okay, what you've got to ask yourself is this question: what times r would give me 2r to the second power? What times r is going to give me 2r to the second power? My tree. 2r. So that means above the r column, you write 2r. You write 2r above that second term. Now, when we wrote the 2 above the 10, didn't we take 2 times 5? So we got to take 2r times r plus 3. Are you ready? What's 2r times r, Olivia?
No, I should have a question.
Oh, what?
Why wouldn't you go with 2r squared?
What?
Why wouldn't you go with 2r squared?
You got to equal 2r squared. And you're taking it times 1r. So you can't take 2r squared times r. You get 2r cubed. We want it to be exactly 2r squared. So 2r times r is going to give us 2r squared. So I'm going to take 2r and multiply it through r plus 3. So 2r times r is 2r squared. And 2r times 3 is how much? 6r. At this point, you have to subtract out here. Be very careful. 2r squared minus 2r squared is now gone. You have to make it go away. 5r minus 6r. What is that? Negative r. Then I got to bring down this minus 3 guy. Now, what can I take times my r to give me minus r, Octavia? Negative 1. Negative 1 times r is negative r, and negative 1 times 3 is negative 3. Now, remember how we got to subtract it? Now, here's what I really hate about this. You got to think about subtracting it, but then what does it do to all the signs on that bottom? Basically, what's going on here is they're going to be opposites, and what would happen when I take negative r minus negative r? Falls out. Negative 3 minus negative 3 cancels out. 0. So the answer is 2r minus 1.